In this video, you will learn how to derive the Pythagorean identity of sin squared theta plus cosine squared theta equals 1 by using similar triangles. First off, you have to have a triangle. A right triangle with an angle of theta, and then the hypotenuse, a unit of 1. What we're going to try and find now is the cosine and sine of this triangle. To find that, use the adjacent side, which will be A, which is what we're going to put, and then B for the opposite side. To find the cosine of this triangle, it's going to be the cosine of theta equals the adjacent side over the hypotenuse, which that would be cosine theta equals A over 1, because A is the adjacent over the hypotenuse of 1. Anything over 1 is itself, so cosine theta equals A. So now we can substitute A for cosine of theta for this side. So this side now is cosine of theta. Now to find sine, it's the opposite, B, over the hypotenuse, 1. So sine of theta equals B over 1, which the same thing. Anything over 1 is itself. So sine theta over equals B. So now we can cross out B, and it's sine of theta. So now this side is cosine of theta, this side is sine of theta, and now 1. So now we find those. So now we have to find the altitude, which it starts right here, and it's kind of like this imaginary line that breaks up this original triangle into two similar triangles, which one is right here and one is right here. So now let's take this long side right here and call this X. And let's take the short side and call it Y. So now let's find the right side, which is the short leg value of Y, which is this triangle right here, this orange one. So the hypotenuse of this orange triangle would be cosine of theta, and the short leg value would be Y. Now what we're going to do is try to compare this orange triangle to the original one by making a probability. The probability will be cosine of theta over 1, which this comes from the original one, from this angle to this angle, which is cosine. So this will be the short side for the original one, and the hypotenuse is on the bottom, which is 1. So the numerator is the short side, and the denominator is the hypotenuse. So now for the orange triangle, it's Y over cosine theta. So now we have our probability. What we're going to do is cross multiply, and the cross multiply will equal Y equals cosine squared theta. So now we know what Y equals. So now we can cross out Y and put cosine squared theta. So now we figured out the Y. So now to the long leg value side, which is the green triangle right here. So now this part, this long one right here, equals this, and is X. But the hypotenuse of this green triangle will be sine theta from the original one. So now we're going to make a probability for this one, which is sine of theta over 1, which is the original, the opposite side over the hypotenuse, which is this right here, and right here, equals the green triangle, x over sine of theta. So same thing as the orange triangle. You cross multiply, x equals sine squared theta. So now you found x, which is sine squared theta. There you go. So now if you plug both these in, you take this triangle, put it in right here. It's good. Put this green one, it's good. A little different just because I cut it, but it fits. So what we found out is that x plus y equals 1. So then we found out that x equals sine squared theta and y equals cosine squared theta, which is what this is all about, is that sine squared theta plus cosine squared theta equals 1, which makes this true, which now we've learned that sine squared theta plus cosine squared theta equals 1. And in this lesson, in video, you've just learned that how to derive the Pythagorean identity using sine squared theta plus cosine squared theta equals 1.